Hey guys, this is Carl Artemis. We're over here at the Mount Juliet Library. We're going to do a follow-up lesson to that short lesson that we did about the Sophia project. If you remember the Sophia project, that's the plane that you see over there, is able to determine the fact that there's water on the moon, and we're able to do that from 250,000 miles away. The Sophia project is an outgrowth of the Artemis Program. That's what we're going to be talking about today, the Artemis Program. The Artemis Program is named for the Greek goddess Artemis, who is the goddess of the moon. Her twin brother is Apollo, who is the god of the sun. Now what happened is this, folks. In October, we discovered the fact that there's water on the moon, and we think that that water is the result of the interaction between meteorites that are hitting the surface of the moon and the interaction of solar wind that's hitting the surface of the moon as well. We believe that there's about 12 ounces of water per cubic meter. Just to put that in its proper perspective, here on planet Earth, the Sahara Desert has about more than 100 times that amount of water per cubic meter. So the amount of water on the moon is relatively, it's not a whole lot, but the fact is that it really does exist. Now, to understand that, we have to understand something that we call electromagnetic energy. Electromagnetic energy is going to be all of the energy that the Earth is going to receive from the sun. Visible light, Roy G. Biv, represents a relatively small amount of the energy. Now, even though you've got all sorts of other energy, we can't see it with the eye. But by use of various types of telescopes, we're able to see things that the eye can't see, including thermal energy, and that's what they're using to establish the fact that there's water on the moon. That's part of, if you remember the Sophia program, I told you it's the stratospheric observatory for infrared astronomy. What this does is by getting the plane above the Earth's atmosphere, we're able to see thermal energy that normally we would not be able to see before that. Now remember, I'm not saying seeing that we actually see it, but we're able to see it through this special type of a telescope. For example, look at this over here. We can't see heat energy, but by use of thermal photography, we're able to see where this apartment building is leaking heat energy. Or if you take a look at the one underneath, last week I told you that each particular type of energy has its own signature based upon the type of matter that it is. So we're able to see thermal imagery literally light years away, and based upon what we're able to see, because it has its own unique signature, we're actually able to see what we believe actually exists in black holes and all sorts of things that are found out in space. Like I've told you folks, this is all part of the Artemis program, and the basic idea of the Artemis program is, in time, we want to establish a colony on the moon. By establishing a colony of the moon, this is what we think it's going to look like. The top picture is going to represent the living quarters that are going to be on the moon, and the bottom part is going to represent the various points of colonization. We like the idea of being able to establish a colony on the moon because the moon's gravity is so much less that we could use that as a launching point to go to Mars. And as a result of that, it's going to be so much cheaper and so much easier. But first, we need to establish some type of a presence on the moon, and that's the purpose of the Artemis program. Now, just like we did with Apollo, the Artemis program is going to create all sorts of technological advances. See over there, the top picture? That's the lunar rover that we had with Apollo 15 in 1971. Take a look at the new Artemis prototype for a lunar rover that we're going to start having in the 2020s. It's like the difference between my first car, which was a 61 Studebaker, and a really hopped up, really cool sports car. All this technology that we get from the Artemis program is also going to be able to apply over here to various things that we see on planet Earth. Tentatively, the idea is we're going to land at the lunar South Pole, where the average temperature is a toasty 8 degrees Fahrenheit. And the reason why we want to do that is there's going to be a greater availability of ice that we're going to be able to use for water, and we're going to be able to use for generating oxygen as well. Big problem is, how are we going to send these samples back from the moon to planet Earth? That's one of the things that we're going to have to be looking at. That's what we see over there as being the Lunar Deep Freeze Challenge. In addition to that, we're going to have an orbiting lunar station called the Gateway. It's going to be similar to the International Space Station that we've got orbiting around planet Earth, but instead of orbiting around planet Earth, it's going to orbit around the moon. That's going to be an area where we're going to be doing a lot of short-term lab experiments that are going to indicate to us the differences between the Earth and the moon. It's also going to allow a spot for scientists to live for a relatively short period of time. From a historical point of view, the Artemis program has set as its sights to get people back on the moon in the year 2024 from the United States, and at least one of those people is going to be a woman. Consider this. 65 women have gone into space. Out of that 65, 50 of them have been Americans. Two of the most important are Sally Ride and Krista McAuliffe. Sally Ride is going to be the first woman in space. Krista McAuliffe is going to be the first teacher in space. Sadly, the death of Krista McAuliffe on board, along with the rest of the Challenger crew, is going to demonstrate to us how absolutely dangerous space travel can become. See the picture over there on the left? That's the explosion of the Challenger. All the 7 astronauts on board the Challenger, I want to say their name: Ellison Onizuka, Krista McAuliffe, Greg Jarvis, Judy Resnick, Mike Smith, Commander Dick Scobie, and Ron McNair. All of them died in that. The reason why I wanted to say their name, everybody knows Krista McAuliffe, but there were 6 other astronauts that passed along with them. Apollo 1 is going to be the very first time we're ever going to lose astronauts. Excuse me. On February 21st, 1967, in a pre-launch drill, a fire would break out on board the space capsule. Unfortunately, the astronauts were not able to escape that, and they sadly were burned alive inside the space capsule. Ironically, we've never lost anybody in space. The astronauts that we've lost have been lost in launch, pre-launch, or re-entry. But actual space, Apollo 13 is the closest that we ever came. The astronauts over there are Gus Grissom, Ed White, and Roger Chaffee. And finally, February 1st, 2003, the Columbia is destroyed. What happens is, on re-entry, parts of the Columbia are going to break off. It's going to do damage to the wing, and the end result is they are going to perish along with pre-entry. President Bush said, he just gave a beautiful, moving speech about the astronauts. I'd just like to share a part of it. The same creator who names the stars also knows the names of the 7 souls that we mourn today. The crew of the shuttle Columbia did not return safely to Earth, yet we pray that they had returned safely to home. Those people are Dave Brown, Laura Clark, Mike Anderson, Ian Ramone, Rick Hubbard, Kalipa Chawala, and William McCool. Those people, along with the other astronauts, are the ones that we pray safely made it home. There are dangers in space, folks. Never make a mistake about that. That's it.